Okay, so what did we study in the last class? Okay, so we asked this question of when does this A inverse exist, right? Inverse of a matrix exists. So in order to answer that, we looked at various things, right? For example, we looked at what is known as the kernel, right? So Ax equal to 0. So if you have an x such that x not equal to 0 and Ax equal to 0, then the matrix A cannot be invertible, cannot be inverted, right? And also we looked at various other algebraic manipulation when it comes to matrices. For example, if you take the product of two matrices and look at the ijth value or ijth entry, then it's given by summation over all L, Ai, L, B, Lj, right? So that's how we write. And similarly, trace and few other things. And then we looked at matrix transformation, right? So suppose Ax equal to B is the equation and you want to solve for x, then I need to know what is A, what is A inverse, right? So supposing if I could transform this A into some matrix by making a series of what is called elementary transformation, right? So what is elementary transformation? Can somebody tell me? What is elementary? Huh? Right? If you exchange rows, then that's an elementary operation and it's invertible. Okay, what else? Scaling a row is also an elementary operation, it's invertible. And then replacing a row by a linear combination of that particular row and other rows, right? So that is another linear, elementary transformation. So supposing if I can sort of sequentially transform this matrix A into an identity matrix using elementary transformations, then I can go backward also. That means I can write the product of elementary transformations times A is identity. So you know what the inverse is, right? So we looked at one example also towards the end. How do you get to identity matrix? And in doing so, we did some sequence of elementary operations. Elementary operations correspond to multiplying by a particular matrix, right? So all that you have to do in order to compute the inverse is what? So look at the product of those matrices, right? In some sense, right? You know how to find the inverse. And we also finally looked at a few properties of inverse. Product AB whole inverse is B inverse A inverse, which is again easy to see. A transpose inverse is A inverse transpose, and so on. Okay. So then we saw, well, what next, right? So towards that we briefly talked about closeness, norms, inner product, and so on. So we will look at a few other things and come back to these closeness notions today. Okay, so let's get started. Any questions? Okay, so before I start, there will be an assignment which is scribing the notes, right? So what we are going to do is pick randomly 3 of you and ask you to scribe certain lectures, right? Or a particular lecture. So there is a TS have scribed notes, I think lecture 0 and lecture 1. You can go through that and you'll get a fairly good idea. So the idea is you have to go through that part of that lecture and or your notes, whatever, you have to scribe. You have to basically explain what is being taught in the class, and you can use your own ideas, whatever. Okay. So one thing is if 2 students copy, for example, there is like more than 60% overlap, even in terms of English, everything, then you'll get 0. Okay. So don't come cribbing to me, regardless of who. So even if you had given your LaTeX code to the other guy, you will also get 0. So be careful with that. Okay, 0 in the sense 0 for that assignment. Okay, so remember it costs you 10 marks out of 100 towards the end. Okay, so let's get started. So today I think TS will send out an email for those 4. It's random. You wouldn't know beforehand, and you wouldn't know unless all of you collaborate. You wouldn't know who the other person is.